All right, what's up, everyone? We're back for yet another Polymath Salon online, because we keep doing these things. We're joined today by multiple very cool people. If you want to introduce yourself.
Hi, my name is Nicholas. I was previously in the perception of time salon. Very interested in physics, quantum mechanics specifically. Hoping to look at this through more of a physical light through physics and a lot of mathematical principles rather than biology, but interested to see where this can go.
I'm starting my PhD in computational neuroscience in a few months. And I'm just here to kind of join in the conversation and see what's happening. So,
my name is Dugan. I work with the Wolfram Institute, and I'm a mathematician, geometer. So I'll be coming at this discussion of information from a sort of a symbolic logic point of view, mathematics point of view.
And you'll also have Dugan. On Saturday, I believe you're also doing a presentation on the non-Euclidean higher dimensional space visualization salon.
That's correct.
That's going to be your thing. Awesome. All right, yeah, we'll link to that in the description as well. And then Alon.
Hey everybody, I'm Milan. I am co-direct the Machine Perception Cognitive Robotics Lab at Florida Atlantic University, and I am working on a count of cognition based on autoregressive next token generation. That's what I'm. So I certainly think that is relevant to today's topic.
Hey, I'm the resident PhD physics student of the MPCR lab. Mainly specialized in general relativity and also complex systems. Yeah, so dimensional collapsar theory. Basically, it's what should happen in high dimensional general relativity if you have compact spaces. So it's a bit elaborate, and I don't know if I have time to really explain it right now.
Okay, all right. So today, to kick this thing off, I want to start by asking, how do you all define information? What actually is information? Any takers?
I mean, I'm I've been indoctrinated in the Shannon kind of school of thought, but I think that's a theory of communication. I certainly don't buy that that's like the way that captures our colloquial, sort of in innate sense. It's not innate, but kind of how we colloquially think of what people mean when they say the word information. I don't think it's that well captured by Shannon information. Do I have my own perspective? So difference. Some people say difference that makes a difference. I think inherently it implies an observer, and so whatever definition of information you're going to have is going to have to somehow incorporate an observer. I guess if it's the tree falls in the forest, right? If a bit flips in the void, and no one is there to observe it, is there information in the bit flip? I guess I think of information as inherently being information to somebody, but that's as far as I'll go. And I think Shannon information, although it certainly takes into account certain or it's useful in relation to transmission and communication. The inherent definition is kind of just a probability distribution. It doesn't really take observing directly into account. So I feel like there's something missing there, and in sort of my gut sense of what information is. But that's the kind of thing I think would be nice to flesh out and discuss.
Right. So Shannon had information theory in regards to signal to noise ratio on lossy communication lines. It's like, how do you pick apart noise from or information from the noise? And then there's sort of Shannon information in the digital sense, when you have like a bit stream and you need to know how much information content is there. So there it's about surprisal of anything that you wouldn't expect. It's sort of so if someone sent you a bits of one constantly, you're not getting any more information than if someone sends you a bit where it's more complicated. Okay, then there's symbols and their relations. The symbols don't have meaning, but the relationships do. So
So
information.
would you say information is then relational?
I'd say it's relational between arbitrary units of either you're talking about bits or you're talking about like symbolic logic uses symbols. Digital communication uses bits, and analog communication uses waveforms.
Are you suggesting that, so you think that that these different formats or something, or do you think they can't be handled by sort of the Shannon information kind of perspective? Or are you sort of suggesting that there's limitations to thinking about just bits, that the symbols, for example, in relational information maybe just not captured? But
Well, in bits, it's like how much information is how much you can compress the bit stream. And so it's like, if you have a purely random bit stream, then you can't really compress it very much. So there's a lot of information there, a lot of entropy. So there's a correlation between information and entropy in the bit stream.
yeah, well, yeah, compressibility though.
But as far as like, these are the three separate domains that I highlighted that I think are, each one is carrying information, but in a different way.
Do you think that information and language have some level of, they can be almost synonymous? Is there any way you can view the thing where you can say language and information is synonymous? Because the way I kind of look at it is that, you can have very ambiguous text on something, and it's only until you're using your cognition as the observer to constrain something that it brings any meaning, right? Like, a simple experiment to try with that is that, if you listen to a song lyric or whatever, is that a lot of things in the arts, in particular in music, is they're purposely trying to be more ambiguous, right? So there's multiple ways of seeing the thing that are technically somewhat intended. But even the message that I'm getting across right now to you using the English language, you cannot be interpreting it in the same way that I'm interpreting it in my head. So could you then say, is there such a thing as a literal interpretation of something? Or is it always a subjective interpretation and there's nothing quite actually literal?
Right. So it's like, the difference between a homomorphism and an isomorphism of structure. So in language, you can use words and you can imply like a certain like outline or structure to something. You can map that to like in lyrics. You have these lyrics of a song and you can map that to different like situations, like, oh, how does it affect you in your life? If you want to send it through a lens, you can kind of map the structure onto a more complicated structure and some themes map. And it's sort of a lossy mapping in the sense that there's ambiguity to the different things you could apply it to, the lyrics. In the case of like symbolic logic or mathematical proof, it's like you have a statement and it's very precisely defined what it means, and you have like a rule of inference, and it's symbolic logic. It's very precise. Or you're working on like a computation. There's no ambiguity there. But that precision is also like relational in the sense that you have a bunch of symbols that don't mean anything, and then you've set up again some sort of symbolic relationships between those, again expressed in symbols. So it's a little hard to think about symbols all the way down there. But.
It just reminds me of the abstraction thing we were talking about the other day, Alon.
Yeah, it sure does. And yeah, definitely highly related. So on a sort of on a continuum, you can start to think about this way. What Shannon tried to set up, his purpose was ultimately what he was trying to do was solve a communication problem. And you have to remember, he was an engineer trying to solve a very specific telecommunication problem. And what you want there is literal identity. You want whatever's on this side shows up on this side, and it's very concrete. There's a bit on this side. We want there to be know that there's a bit on this side, that what happened here. We want to know precisely what happened here so that we can reproduce it on, tele, right, somewhere else. And so precision is like fundamental, and he wasn't certainly responsible for the idea of digital, but that's sort of baked in to the entire theoretical framework is starting off with like bit flips, and we're 0 and 1, and there is no ambiguity, right? We're just literally trying to get that content over here. And again, you could do things like compression and things like that, but fundamentally, it's literally the exact same information, like mathematically, it's informationally identical. And then, go all the way to the other end, and it's like, here's a poem. And like your brain and my brain are going to do completely different things with that poem. And what information is in there. Now, we could talk about the sound waves, and we could talk about the literal text that's sent, and that's communication. That's like standard communication, in the sense that you use Shannon's formulation and say you're supposed to hear these exact phonemes and in this order, so that's the words you hear. And you can think of sort of the word level, right? And that's like communication at that level. But then we have the important level, right? In some ways, you need that as a starting point. But what does that thing do, right? So in a telecommunications context, what it does is literally just duplicates itself. Okay, so the message is sort of here and now it's there. But when I'm talking to you, of course, that's not what we have in mind at all. I'm producing some telecommunications. It is traveling, and it's going into your brain. In some way, I'm literally sending these bits. But then what do those bits do? is the important question in the case of language. And as you're pointing out, Addie, it's everybody's brain. It's the understatement of the year is what I was thinking when you said it, right? It's not just that everybody interprets it, somewhat differently. It's like every brain is kind of infinitely different from everyone, and the way you're going to interpret these, any particular language construct is probably going to be very, very different in some ways. But then, of course, also the same. And so, when you're talking about language as a directive, like I say to you, please do this action, you kind of want precision. And so you want it ultimately to also be, of course, shareable so that we can coordinate and do all that stuff. So it's actually just a very interesting, kind of thinking about these poles of like precise copying of information or something like that. And then what does the information do? What does it do in another system? What its impact, which is kind of the purpose really of information when we think about it. In terms of communication, even in the Shannon sense, you're sending the thing, but the reason you want that particular set of bits to go from here to there is because you want to do something in somebody's brain, ultimately, right? So it is certainly at least related in terms of larger functional reasoning. But again, I think it's important to remember that the Shannon information and the kind. He was giving a measure of something. He wasn't really even defining it. He was just trying to say, given a certain distribution and a certain, like things like noisy channels, you want to be able to make determinations about, if you the known probabilities about the likelihood of certain messages, and then you can represent those things economically. Then how many messages are you going to need to send this information? That's really like, how many packets are you going to need to send? That's the kind of question they were asking. So we can reproduce this exact thing somewhere else. So it's again, I don't think it captures many people's colloquial notion of information, but it's a very good starting point for precision. And I like precision. I think precision's a good thing to start with. It's much less precise to say what's, the poem, how are we going to measure that, right? Like how it's different in your brain versus my brain. And to the point that it's so hopeless that I'm like, well, what can you do with that? What quantitative things can we even say about that? It's very difficult. I think large language models are an opportunity maybe to think a little, maybe, I'm not sure, think about quantifying stuff like that, but yeah. Yeah, they are.
In a practical standpoint, it does seem very helpful to actually have different perspectives as observers. Or you don't actually want everyone interpreting the information in the same way, because when you do that, then you're going to get the same result usually.
Well, it depends. If you want, so like, I think a primary functional language, or not the primary function, is ultimately coordinating behavior in some way. And if there's a shared task or goal, I want everybody to sort of understand it the same way to some extent, right? If we're all, we're hunting a bison.
There needs to be some invariance. There needs to be some invariance, right? Like, the analogy I was saying earlier to you about, like, if you're on a sports team or something, each person is actually technically doing something different, yet they're contributing to the same goal. And from their perspective, they may not even know that they're contributing to the same goal. All right, you and I can just do our jobs as people, and we could be contributing to a goal that we don't even have in mind. And yet, at a larger scale, if someone's observing that, you'd say, oh, well, obviously they're doing that. It's like when Levin famously talks about, the perspective of, say, cells, is that the cells don't necessarily, they're not,
They have no clue.
actively thinking in the same way about the greater whole of things. And yet they're still acting in a form of coordination with the whole. And I think that is a very fundamental aspect of understanding what information actually is, because it could mean something different to you, but you're still contributing to the goal of somebody else or something else.
I think it's a deep point about, but I come in the other direction, which is like when we communicate shared goals, let's say, what's interesting to me is that, if I say, let's walk towards a certain spot, right, in the room, let's all do that. Let's say we're all in the same room, right? Now, each of us is going to do something different in order to achieve
Correct.
that same goal. And so there's a sort of an invariance there, but then what that actually means in relation to, guiding your behavior, for example, is it's sort of the same. It's sort of, different as well. So yeah, I don't know. I'm trying to think, how do you kind of define these invariants in relation to information as sort of, so information, I guess the word information is what's is problematic to me, because it already is and when I say to me, I mean because I have this notion of information sort of being a property of a system, whereas you're talking about something like what people do or how people interpret. So yeah, I'm not sure exactly how you merge sort of the formal sense of information with the kind that you're discussing.
Yeah, I mean, I can obviously speak more to my whole cognitive biohacking, whatever perspective lens on, because everything gets tied into that. But see, it's good because it's kind of a goal. This is all just a wacky way of trying to get to that goal of something really interesting there, right? Which probably has its limitations just by taking that goal. But my thing is that there are these different lenses that you can experience things through, and we talked about that thing in previous salons or whatever, and it's like, I'm curious why that's even possible, right? Why is it that you can take, I can read, I say that, to come up with the free energy principle, all you really have to do is read a thermodynamics paper and think that it's talking about behavior and cognition. Because if you go and you pull up a thermodynamics thing on some, journal or Wikipedia or anything, if you actually read it as if it's talking about behavior, your mind will try to make that sort of fit that idea of what behavior is, and you're going to be reading something that sounds like the free energy principle. This is something like literally anybody can try, as long as they know how to read and comprehend stuff. And the fact that that's possible is interesting, because you'd never think about actively going and reading something under a completely different context lens, but yet doing that gives you a very interesting result, right? Like I think I've told people in the past, like when I listen to a lecture or a video on like biology or something in math or physics, I usually get myself to think about something completely different. Like I'll rarely actually ever listen to a lecture and think it's and like go in with the context that, oh, this is talking about a cell. When I hear a cell, I'll think it's talking about something with music or sound, or with like an organization or an economy or whatever. Like, and it really breaks you out of that box. And there's almost a kind of quality associated with that. Like there's this very interesting feeling where you feel things are more vague or ambiguous, but you can kind of choose how you view it, right? And like I think I also gave an example at a previous salon, is that if the goal in mind, the thing that's coordinating the behavior and the perspective, is, say, you're hungry, right? You're probably going to be able to look at things around you and be like, well, what could I eat that's in this room here? And some people, as Michael and Lindsay may remember, some people will famously want to eat paper, maybe because it's the closest thing to food that they can kind of see, right? But that's also probably how we made tools, right? And it's not just, okay, it's the ability to break out of that one specific perspective or context. Like, yeah, the stick is a tool, but what else could be a tool? okay, yes, this plant or this, this muscle meat of this animal is a food, but what else could be? Right. And so what I think looking at information from that perspective, what it does is it lets you see all the other things that it could be.
That's very interesting. So it's what you're talking about is context switching. So like you go to one piece of information and it has all the structure, like quantum physics, right? Or biology. And you abstract the relationships away from the objects that they're relating. And you have this like network of relationships. And you take that network and you apply it to other objects.
Yeah.
So this is like the heart of category theory. It's taking the relationships and applying it to different substrate. In the case of like, caveman goes to like a tree and it sees like this wood sticks, branches of wood holding up all this structure or all this weight, essentially. You realize that those things are rigid, and you can use that rigidity to construct other things that aren't trees, or you can use it to use it as tools for other things.
Yeah, and actually,
Or use it for fuel for fire.
And yes,
exactly.
I was going to mention that in one of the other salons as well. If you remember when I was talking about the way that I was visually chunking information, like applying like a wood table, like an aspect of the wood table to the car, or vice versa, and depending on what I was selecting for, you can get a different result. I think that's talking about a very similar thing. And it actually does remind me of something I used to do a lot when I was younger. I mean, I still kind of do, but I used to do it more. Is that I would try to like visually multiply things. Like, what do you get when you multiply an orange by an apple, or like water by sand? And like you think in these really, really interesting ways, which seems like they're kind of out there and useless, or kind of what's the point of it? But that's, when you I can at least speak for when you're designing things, thinking in that way, is that's very useful. Like a lot of times as a designer, if you're designing, a fashion piece or something inside of a car or building or whatever, is a lot of times in that creative process, you're taking one thing and trying to almost overlay it and multiply it to the other, right? And you're selecting for certain traits. You could, dare I say, that's almost kind of like what evolution is doing in a weird way, right? I think there's multiple lenses of viewing what evolution is, because it's an iterative process. It's selecting for certain things, and by selecting for certain things, you may not be selecting for other things.
But what about reproduction? Sexual reproduction is kind of multiplication. That's not.
Well, could you say? Well, exactly. And when you reproduce, it's sort of a selection of certain things, but it's not like you're rigidly selecting.
Sexual reproduction specifically, right? I'm saying that,
yeah. And anyways, my point with this is that I think if we were to reach out to other people that work as if we got designers and artists and mathematicians and physicists or whoever together, I don't know if how much what they're doing mentally when they're doing their tasks and their thinking are as different as we think they are. I think they're actually quite similar, right? And I think when you I guess you could say there's a difference between what a really good artist and a really good mathematician is doing versus ones that we wouldn't consider to be as good, which again is observer dependent and subjective according to what. But I don't think they're as far away as processes, because when I would think about multiplication before I ever knew what multiplication was, I was just thinking like, okay, like I'm just applying these things visually, or what does this sound like when it's applied to this other sound or this thing. And you can kind of cross between sensory modalities, and you can get some very interesting effects, right? And what I've noticed is that if you take a touch sensation, like you're feeling a texture, and you multiply that to say like a word or an idea, it can get translated in various different ways. It can almost start to feel like its own different qualia. And that one starts to get really hard to describe. And maybe qualia is not even the right word, because I think people, I guess we kind of throw that word around a lot. But I think there's some very interesting things. Go ahead, Dugan.
I think it's appropriate. I think our cognition is basically our symbols that we're using in our minds are sensory qualia. And then we have like notions of how they're related, and we think with those types of objects. I'm not sure if there's a qualia associated with relational, the relations themselves, but when I think typically it's visual, for instance.
Right.
I will say, I think that a lot of people who are great at, like math and these sort of hard sciences are also pretty great in the arts. And I think it's vice versa too, even though I've spoken to a lot of people who are like artists and musicians who think that they're horrible at math. And I just don't think that they ever had a good math teacher, because they pick up pretty quickly. So I do think that they're sort of correlated, or at least related in some way. Because I don't think I've ever met someone who was like really great at making music or really great at, creating art or even fashion design who also wasn't, or choreography, who also didn't have a lot of skills that could be applied.
So in other
in
words, sorry,
things.
you think there's one thing really, like it's called thinking or something,
Yeah.
and then there's just different manifestations or different directions of it. That's
Yeah.
a very that's kind of taking a G standpoint, right? Intelligence, which
A little bit, yeah.
which
'Cause
is
I think-
still not a favor, but I think even academically, as I don't know, I don't follow the literature on this. I mean, there certainly are exceptions, though, right? There are people who are absolutely brilliant in one domain. In fact, I think it's very common. People are quite brilliant in one domain and certainly not brilliant in others. I mean,
Yeah.
they can be musically completely and totally obtuse. And vice versa.
Yeah. But it could be that that's just the way that they're presented with. Like if you show someone whose brain is just, or their mind for whatever reason is just really, really great at this one thing, and you present them something else in a way that's they're not interested in a way that doesn't relate to what they enjoy doing, that they've already, if you go to anyone who wants to be, an astronaut when they grow up, and you ask them to write an essay about, I don't know, something that they don't like or that they're not interested in, they're not going to be interested in writing it, and then they're not going to perform as well, and then they're going to think that, oh, I'm just suck at English. And it's like, you might not suck at English. It's just not being presented to you in a way that's going to get you excited about it.
Mhm.
And then you also take people whose personalities, like I know I teachers did not love me in school, right? And there were a lot of times where I thought that I was horrible and didn't enjoy subjects at all that I ended up really loving once I was able to learn them in my own way. But until then, I loved history by the time I was 15. When I was in 6th grade, I thought it was my worst subject and that it was the worst thing that had ever existed in my entire life, right? So between 6th grade and 9th grade, that changed pretty much only because I was able to learn the things that I was interested in and then expand from that, instead of learning a curriculum that wasn't, sort of tailored to what I think or my thought process.
One way to think about it, there's interest. Why, we find things interesting, and it's just that you found it interesting, and that's why you care. But another way to think about it, and maybe because I think this is what you're getting at, is that you found a way to think about it.
Exactly.
But it suddenly made sense to you, and everything. If you understand, everything's interesting. Of course, history is very interesting if you have the right, if you can think about it, right?
Exactly.
Okay.
I think a lot of people who are artists and who are musicians probably took a math class when they were in the 2nd grade and decided from then on that they were horrible at math. And if you tell yourself you're horrible at math and you don't put in any effort to learn math because you're like, nope, I like art, I like music, I don't like math, this is something that I suck at. And I tutor. I met one girl who was like, I don't want to be good at math because like pretty girls aren't good at math. And I was like, oh my God, well, let's not say that, but she was great at math, right? She just was getting bad grades in it because she had no interest in doing it and couldn't find any motivation.
That's the other kind of interest. That's the interest from like, I don't think that's a good thing for me to learn. That's not important, right? And then there's the other kind of lack of interest, which is like, I don't get it. And it's not interesting for that reason. And sometimes people find things interesting. Why do people find certain kind of very, very obscure mathematics? Why is that interesting? They're not going to tell you it's because it has these implications, or because I have an external reason to care about it. It's because they see the beauty of the internal beauty, because they understand it, right? It's just it's interesting.
Exactly. Yeah, as a mathematician, I can attest to that. It's like we go
I
on
could
to
just say something. Sorry. I personally very much agree because I'm at my school constantly and I'm seeing people around me who are just as advanced as me in a lot of respects, and they just don't want to be here anymore. They want to be out of it. They see the math and they want help from someone like me or help from some of my friends who are just as good as me, and they see that and I teach that to them and they get it, but then they don't know how to apply it. So it's more, I think, if we got more focused on applications of things, people could understand it better and actually enjoy the information that they're gaining better.
I
And
agree.
Yeah,
Yeah.
and it's not, again, and maybe I'm just repeating the same idea, but it's not just because they're like, oh, it's useful for this. It's because in thinking about it in an application sense, they'll conceptually get it, right? It's
I also think
like
thinking
that.
is hard, right? Thinking takes a lot of energy, and it's, your brain, it's hard to think, right? So if you're trying to think in a way that you've never thought before, that your brain maybe isn't like geared towards thinking based on whatever other context, whatever else you've been thinking about or you're interested in your life. If you're really into art and then you look at, like, I don't know, an abstract algebra textbook for the first time and you just flip to the middle of it, that looks scary. That looks terrifying. Like, no one is going to say like that looks normal. It's a whole nother language. It's not, you need to learn it, right? But if you teach it in a way where it's not intimidating and where that it's maybe geared towards, and I don't even know how you would do it, but you would have to gear curriculum towards students who,
Yeah, the problem is math as a language is a technical thing. Like, the
well,
problem,
not math as a
that thing
language,
kind of
just
sucks. And
even the symbols.
like it.
I'm talking more about how scary the symbols are.
No, that's what I mean. And that's what I mean. The symbols themselves and having to learn the symbol system.
I'm gonna say
is a pain in
mathematics
the
becomes a
ass,
lot
and
more
it's not
scary when they
pleasant.
start adding letters. Wait, there's
Well,
numbers? Now
letters,
there's
and then you got
letters
Greek.
too? Ah,
I think
You
they
got
geez.
should
Greek
teach us the
letters,
letters
and then
first.
weird,
That's my opinion.
squiggles.
well,
I
don't
think
even get me started on
Let
logical
Lindsay go.
operators.
Let
They
Lindsay
lost
go. Let
letters.
Lindsay finish.
I think it should be letters before it's anything else. I think that we probably are making a mistake when we turn it into a whole nother thing with numbers and everything. If we just taught it as the sort of like, if we taught the sort of like philosophical logic statements with variables before we
Right.
ever taught, into the numbers and into everything else, I think it would be a lot less intimidating for students. And I think students who maybe think that they're not geared towards math or they're just not good at math would realize that they liked it or thought that it was a lot more interesting, because I show like the students I tutor, like I'll show them these like sort of things that you would think are complicated, but they're not really. If you like like you can boil it down, and I'm not doing anything crazy advanced, but you show them what a complex plan is or whatever, right? Like when you're teaching what I is an imaginary number and all of this stuff. And if you do that and you do it in a way that they understand, they love it. Like they get so excited that they learned it and they want to learn more about it. It's just not taught to them in a way that they like feel like they can actually grasp it, understand it, or use it. So
I want to actually inquire on one thing in your
Mhm.
situation. Is have you noticed any difference in the age ranges of people that you tutor, even if it's only like a couple years?
I
Like,
mean,
what's the variance?
I've always tutored pretty much every age. I started tutoring at Mathnasium, which is K through 12, and then a year after that, I did K through college, and I still do. I have noticed differences in critical thinking, which I've spoken to Alon about a little bit, that I think might come from a lack of math skills because of the internet, honestly, because people have looked up their answers, and I've noticed that since Mathway and all of these other things, and now ChatGPT exists, where you can just plug in everything that you need to plug in, and they're just learning how to do the exact problems that are going to be on the test with like two numbers changed, and it's the same exact thing every time. Critical thinking skills generally, and I mean this super generally, not related to math at all, just order of events, understanding the world, processing information, like has decreased a lot for students who are in K through 12 during COVID.
I also sort of not gonna pivot, but a slight pivot is, we're talking about math and all these types of things, right? And it's like, why math at all? Why does it look like this in the first place, right? You can ask that question. Why math in the first place, right? And then the second thing is people like to talk about the unreasonable effectiveness of mathematics. Why the heck is these numbers and letters and whatever the heck, whatever the heck it is, why does it seem so helpful for our goals? I think this is a very, very deep question about information, actually.
Yeah.
Yeah, I can speak to that a little bit. Some thoughts I have. So
Go ahead.
in our universe, there's like object permanence. So if you go to an empty box, and you put like 2 rocks in it, you close the box, you come back later, you open the box again, what's going to be in it? Assuming it's unperturbed, it'll be the same. Two stones, right? And like in math or sort of a computer system, you'll say like, oh, I need to assign the value x to the variable x, the value of 2, and you enter that, and the kernel stores it, and you recall the value of x. It'll be 2 again because it's unperturbed in the kernel. So you have the persistence of information on one side and persistence of objects on the other side. In our universe, we should be so lucky that we don't live in some like bizarro Adventure Time reality where you open the box and dragon comes out instead of 2 rocks. So the fact that our universe has conservation laws and its physics lends itself to a sort of way of computing quantities where there's a persistence of variables and the way it's computed.
There are parts of that where it goes into the quantum realm where it's a lot harder to computate those things because it's everything at once instead of just one pathway.
Yeah, there's quantities, the fields, the energy in the fields is preserved, but it's wobbly, and we can't see all the wobbles. So we have to have a probabilistic distribution of where the wobbles will end up wobbling. Is my view of it.
So I come back to the math question. So I have a question related, and it's just a way of answering the question to understand, which is, how long are we going to need math as such to exist? Because what math really is it's a symbols manipulation system such that you can run a recipe. And if you know the recipe, if you're somebody who knows how to do these operations, you start with one thing and you end up with another. There's an algorithm that you run. You can do it on paper. You can do it, in whatever medium. But it runs sort of on. It actually is. But it's sort of a little bit cybernetic, right? It's like you're working with these symbols, but it's the person who's doing some sort of operation over those symbols. And then if you do that the right way, you start with one thing and end up with the other thing that you want, right? You get an answer. And that is the purpose of mathematical symbols. And I guess I'm wondering to what extent we're going to indefinitely need that, or how much are people now actually running symbols? They're doing it to kind of work through ideas, but then by the time you actually need the answer, it's all done by computers, right? So you figure out, maybe theoretically you're working with the symbols to work things out, but then once you've done that, you're going to instantiate it. Anything that really ultimately you're going to use is going to get built in computers. And now we can tell computers to do things in different ways with English. We don't necessarily need to use the symbols to tell them how to do it. We could say integrate over this function, and we can just tell them without having to even use literally the physical symbols. And then that's like verbal math. And then maybe you can even do it more semantically and more colloquially. Like, I need to know a measure of this thing and how much is going to over time. What's the total amount? And you don't even use the word integral. And yeah, I don't know. I just want to open up that question as a way of answering what I think math is, and the symbol kind that a lot of people hate. Maybe there's good news in not having to use it as much because we don't have to compute as humans in the same way.
So I sort of agree in some ways. I don't know how much you're going to need to, know about basic sort of like arithmetic skills, like as they come right now packaged for
And I don't just mean math, addition and subtraction. I'm talking about integration. I'm talking about
Yeah.
formulating the symbolic representation of a large language model as a symbolic form. Nobody uses that.
But
You
it
do it
used
on paper, but you never do it again.
So, but I think that the important thing to connect is that math used to be a study in logic. And I think that we've deviated from that, but I don't think we should have.
What do you mean math is used to be? I mean, math has always been used mostly mechanically to
Uh,
calculate stuff.
Yeah, but I mean, to calculate logical statements in philosophy too. A lot of great
That's
philosophers.
not what most of math is. But math historically, the symbols were built for industry. not
For
for
logic, I would imagine that's sort of
in some ways,
Um,
but oh, sorry.
deductive laws of inference. It's sort
no,
of
that's all good stuff, but that's not what mostly
you
what math
know,
is used for. And
P implies Q, Q implies P, therefore
That's what I'm.
we're talking
I
about
think
that,
that
but that's
we
not
need to move-
I'd say
Logic.
math is a formal language in a sense.
yes, it is a
That's why
formal
we
language.
invented logical operators for it.
It's certainly a formal language. That's precisely what it is, but it's not even. Yeah, I mean, it's barely even representational. Like, and it's just the numbers are. Yeah, but they.
I think it's
You
the
do
way
have a theory and
critical thinking skill.
to art. And
Like,
stuff.
I don't know that you learn math to learn math as much as you learn math to learn how to think critically. And I've seen, like, I'll give this example because my student will never watch
Sorry,
this
yeah.
probably, but she wanted to be a veterinarian when she grew up. And someone had mentioned like, oh, it's so sad when, they work on like small animals. And she was like, well, that's why I would never work on a small animal. And I was like, that all animals start off small, right? And I said it sort of as a joke. She was horrified. She had never considered it. She had never thought about it.
Yeah, no,
It sounds silly, but that's indicative of a pattern because she got A's in math in high school, right? Like, I think that when we think about math, we are thinking about integration and all, and that's, I think, worth thinking about in a lot of ways and worth applying in a lot of ways. But I also think that generally speaking, like, high school math probably has a pretty high correlation with just like understanding the world around you and understanding cause and effect and being able to go backwards and work through certain problems or find problems before they come up, because I think that's the example I give, but there's a lot of examples.
That student did well in math, and you're saying she wasn't good at critical thinking.
No,
So-
well, she did well in math because they just let her go through. Like, she was pushed along.
Oh, you're saying that if she
Yeah,
had
she did
proper
thorough-
education. Okay.
Yeah.
I
it's
want
a-
to jump in here for a
education.
moment, adding to Lindsay's point, actually. In other conversations, I kind of talk about, like, how medicine and biology needs more of a physics or mathematics perspective. And it's not that, oh, you're literally using the physics or math to literally do this thing or whatever. I mean, you can, but it's more about the way you think in math and physics, right? The sort of very critical, rigorous. It's rigorous, and you're trying to really connect things. Like, I think it's much, in a lot of ways, it's sometimes easier to experiment and draw interesting conclusions in physics and math, because with biology, oh, you always have to wait for this one thing. Like, it's not like, if you want to run a program, you can do that on your computer a lot of the time, at least to run a small prototype of things. Biology, like, well, all right, I guess I'll cut myself open and see what happens. It's not the area of entry for that. But regardless of that, I do think that, like, the ways, typically in biology and medicine, the way you're trained to think is not in the same way a mathematician or physicist would. And I think there's I guess really what you're going after with that, to Lindsay's point, is that it trains you to think in a much more rigorous and critical way, right? As a field,
I'm very skeptical of that in the way we teach math, and maybe it's closer to Lindsay's point. I think you can rock math, be really good at it, and you're just a trained monkey. I'm sorry to put it that way, but I think you can just learn the operations, how to carry it out. And we're talking about a mathematician or a physicist. We're talking about professionals. We're talking about people who are actually thinking in these media, right? They're thinking mathematically. That is a rigorous way to think. That
Agreed.
Surely will have spillover to other kinds of domains. But I think you can absolutely be doing it mechanically, and in which case I would think it would have almost zero spillover. And I've had many encounters with such people who are kind of good at the operational thing, but they're not rigorous thinkers in the slightest. And I'm actually skeptical. I'm very skeptical that math, as it's taught, it has any benefit for critical thinking at all. The way as it's taught.
I
As it's
I'd like
taught,
to
it's
jump in here for that.
I can
I'm a high
agree.
schooler now. I completely agree with that. Looking at peers there who are doing good, but I'm doing stuff at home just to, honestly, for fun, and I'm working with Michael on some stuff here and there. And it's fun for me and I like doing it, but I can absolutely see the point where my education, honestly, for math failed me. I had to teach myself most of the stuff because I was just interested in that. So when I would go to my classroom, I'd be ahead of everyone else, but not because I'd be trained to do it already, but because I taught myself to do it already. And I'd help kids, but those kids who were good at it, they'd be trained to do it for specific problems and they couldn't look deeper. They didn't go look up at home, okay, how can this apply to this problem or this problem? So I think that's mainly where education has actually failed us in a lot of senses for math and science, because they give us an equation, they give us a problem to apply it to, and they give us, okay, maybe there's 3 or 4 more problems you can apply this to. Let's see what they can do. Instead of trying to train the mind to think at an earlier level, we leave it to rest up until college level, and then that's when we start training the mind to think, when the people who have already trained themselves actually have a chance to train.
So well said. I totally agree.
So that's taking something, looking at the relationships and context switching those relationships to other substrate objects. As a
And that's what we do a lot in like
Critical
physics
thinking.
and mathematics, because we just look, like when Schrodinger was making his wave equation, he just looked at the regular wave equation and just made his own for quantum mechanics through just his own head.
Mhm.
I mean, I was behind in math. If it wasn't for like having family that was interested in math and them like pushing to teach me math in a way that I would understand it, I would not be where I am right now. If I left it up to the school system, I would be horribly behind. So I think it says something. There was actually I tried to copy and paste it in the chat, but I couldn't. But there was something that I saw in New York. It was like on the subway. It's an ad, and it just says, Emma will never be a doctor, and her parents don't even know it. Today, 55% of New Jersey's 4th graders can't do math at grade level. By 6th grade, it's 64%, less than a third catch up by 12th grade. Even in good districts, yet 80% of students get A's and B's. So it's that was dark to read on like the train.
And again, if it was awesome and look, and it was really teaching people to be good thinkers, then I'd say, all right, what are you going to do? But what it's doing is just chewing kids up and spitting them out, because there are some kids who just are very adept at it. Almost none of them love it, but they're adept at it. And then the other kids who aren't adept at this particular, art form of the symbolic kind of manipulation and things like that. And then
At least not the way we teach it.
not the way we teach it, and then they crash and burn, and and God knows who we've lost.
Yeah.
In the process, what great science and philosophy and intellectual pursuits could have. Yeah.
Well, I think that because now we have so many tools for doing this sort of math that, you usually need those as a foundation in order to be able to teach for like high school geometry or whatever it may be. I think that now, because we have more resources, we can probably start to shift math curriculum towards being more like what it should be, if it's actually going to be helpful.
Very optimistic, and we young people have to push to make that happen, but it's very, very, very challenging. The fact that we're still teaching math the way we taught it like 100 years ago is not very encouraging.
Yeah.
I agree with it slightly, because I think the way we taught it a while ago was actually it was a good way back then, but now because of technology, it's very different, because people will just, oh, here's a problem I can't solve. Let me just look it up on here. Here's the answer. Okay, I don't even need to know how to do it. Let me just put this down and see that.
Devastating.
And if we went back a little bit to where there wasn't those kinds of devices and those kinds of things, I think the old ways did work, where we had to do everything by hand, we had to do it mentally, and that would actually teach people how to think rather than just plug and chug, like a lot of my teachers say most of the time, for just formulas.
You know
But
what's happened? It's crazy, but like, and I'm just realizing that we had this board, this hand calculation way of doing it, and we continue teaching that, and we're like, kids wanted to use calculators, which would have been fine, but we're like, no, you can't use calculators. We can keep using these symbols, and now the machines you can just point them at the freaking paper, and so it's all over, right? It's like
Yeah.
they're not even going to do any of the intermediate steps. They're just gonna if they've been not using computers all
Math
along,
needs
then
to
much better. Like now we're toast. Kids are
math
just
education needs to adapt, or we need to have restrictions on some of these things. Like we need to have restrictions on just AI solvers for this. Like, okay,
yeah, but maybe we
say
shouldn't be teaching then like
No, that I don't think restrictions are. I think you need to make the curriculum in a way where an AI solver, because so right now,
yeah, no, I agree with
is I used to work at Mathnasium, right? That was my first math teaching job, and for that job, they had us like we had a lot of worksheets, and for all of the worksheets, you solved every problem the exact same way, and as long as you knew how to solve the problem, which you can look up how that problem is solved exactly, where to put what for each step of the problem, where what happens to that number, what happens to this number, what you do there, then you can get an A on the exam, right? And I think that that's not just how those worksheets work. Those worksheets are made so that students do better on exams in school. Like that's how it's set up. If you made it so that maybe students are going to cheat on homework, students are going to cheat, but if you made it so that when they are in person, they kind of had to apply something, and they had to actually learn the material in order to apply that material and come up with something that was like meaningful, then I think that that would fix a lot of problems. I was considering not being like going into like math as a subject, and then I took Calc 2, and my professor was really into analytic geometry and all of that, and he was showing us all these proofs in our Calc 2 class that were relevant and like not crazy proofs, but for me that was so exciting, and it made it make a lot more sense than what I saw other students were doing in Calc 2, and that was in college, right? So I don't know that I don't think restricting access to things is achievable, even when every time something gets restricted, like something else comes out. But I do think that you can word problems and develop a curriculum that requires some level of critical thinking and takes away those tools. I learned math on a slide rule and on an abacus. So if whatever you got to do to get a kid to learn it, it can work.
I got that. When I was saying the restrictions on it, I was just pointing out the two possibilities we have. We can either adapt or we have restrictions, and I personally agree with the adaptation much more. Honestly, I think the way we should teach math and even physics in some cases, we should have kids very young, even give them like the very basics. So like we say, okay, this variable is height, this variable is this, what do we see here? And you give them an example problem, and without telling them anything, they have to try and figure out what's happening, and you can help them along the way, but that's going to get them interested, and even just making the very basic equations like F equals ma. So in creating that, they're now thinking, okay, this means that, how do I apply this, how do I apply that, even if it's very basic. But when you're fostering that earlier on, they get the better critical thinking skills that's better for higher math, and that's how we can make them actual mathematicians, even if they're not interested in it.
My second graders understand truth tables more than my college students. So if that's any indicator, right? I think that there are things that kids do pick up on quickly. And you're right. Like, I think that if we do more conceptual, this is how things work, these are variables, this is what a variable.
I would love, and it's related. Kids should be they should be reinventing math. You should be like, you have to figure out a problem. Like you have to figure out which one of these things is going to fit in there. And then if you put them together, what's going to do? And like, they'll have to come up with the idea of measurement, and they'll have to come up with the idea with numbers. Like, I wish they didn't. If kids invented the idea of a fraction, then they'd know what fractions are. I'm convinced that the vast majority of college students, maybe even scientists, have never really thought about what a fraction is exactly. Like, it's just like if
more kids were like that,
they're handed down, like, this is the truth, these are the symbols. No, they're not. Like, somebody made this up to solve problems, and
when they draw the connection, great. Like
What did you say?
when students draw the connections, though, it's great. Like if they're learning long division and they realize, and they're also learning decimals at around the same time, and they
Yeah.
start to realize that whatever number they end up with on the bottom, if they put it over what they're dividing by,
Yeah, but they never learn about base 10. Like,
they get so excited to learn to figure
right,
that out. I don't teach them that.
so
They
getting
learn
the
that.
glimpse, right? They're like, wait, there's a system going on.
Yeah, they're
These
like,
ones, the left and the right of the decimal and all that stuff. But imagine if they had to invent decimals, right?
well, they do. What I'm saying, I don't teach that.
Oh, wow.
What I do is I teach them that at the same time, and I see how many of them draw that connection
That's awesome.
between, okay, all of this eventually becomes like if I'm dividing by 4 and there's a 3 at the bottom, then 3/4 is the same thing as 0.75. And if I keep on going and I put the zeros, then it becomes point. Like when they realize that, they get like they get so excited, and you can watch it.
I feel like a defining moment. in their life.
It's so cute. It's so cute, but we need.
I have to jump off now.
Okay.
But please carry on the conversation. I think there is actually a cool kind of common thread in terms of sort of the adaptivity, right? This is Addie's point, and it's that minds can sort of find their ways to solutions, and then as the solutions are hard defined as this is it. It's like you can do it this way, you can do it that way, and something like that. It seems kind of.
It's like with Gauss when he was 6 and he just invented a new way of finding the sums of very large numbers. And we need more kids like Gauss, but how do we get kids like Gauss? We have to train their minds to think.
Absolutely. And kids can think. Like this is not an issue of like children not being able to think. I don't think that it should be as rare that people are interested in these subjects as it is, right? I
like you go to high schoolers or anything, and you present them with an astronaut, and the astronaut just talked about their life story for 30 minutes. No one's going to ask a question. Maybe like 1 or 2 kids who are actually interested in space stuff, but none of them are going to ask any questions to the astronaut. And if they are, they're going to be basic. They're going to be, okay, what was it like when you were preparing? What was it like when you were actually in it? They're not asking about the science and the facts behind it. But you present a physicist or like a meteorologist to a group of kindergartners. It doesn't matter what scientists or what science that person is in, they're going to ask any question possible just to get an answer. Like they'll ask, why is grass green? Why is the sky blue? Why does sugar hurt my teeth? They'll ask all these questions because they're interested. Their brains at that point are like sponges, and that just kind of leaves when they transfer into middle school and then even more into high school.
Yeah. No, exactly. It's not an issue. Kids are curious. I mean, there are some problems with that right now too, though, after COVID, but that's not necessarily even my direct observation. Like
I don't even think it's a problem with like learning skills, because there are some people who are smart and get good grades, but honestly, I don't think grades are even the whole picture, because there's some people that can't apply anything. And there's people that will say the most ludicrous things. Like at my school, last year we had 5 people expelled because they were in the top programs. They were having all A's. They were doing really good. And then they said some things like they typed them out on a computer. It was the school computer. They got caught very easily. And all of them got expelled because of just how they were talking. And they always talked like that. But this time they actually got caught doing it and they got punished. And these were the COVID kids. These were the people who were at home doing nothing, but also still doing grades because they were just cheating on everything.
Well, yeah, and that's another. There are a lot of problems that came out of COVID for generally just the education system that I think they're starting to get more attention, but I've been noticing them, and it's super concerning. They're actually doing studies. I don't think that the studies are even finished yet. I just know a professor who knows a professor who's doing this research now, that like some students' brains are just not even developing the way that they're supposed to right now. I don't know if it's the iPad kid epidemic. Like I couldn't tell you what the source of it is. I'm not involved in the study.
I mean, let's look at Gen Alphas, for instance. They have a whole language that I don't even understand, and I'm in high school. I've heard words like skibbity, Riz, and I barely even understand what people are saying in my own high school. And then I go to say just like any chain restaurant, and a group of soccer kids run in, and they're speaking
In tongues.
in tongues. Yeah, it's an ancient Mayan alphabet even, because it's so different from the way I speak, from my parents speak, from even my friends. Because um, you forgot the Ohio there, I think. I don't even know what that is for, but you see that, and it's actually interesting because you see it, and you see the evolution of humanity, and we look down upon it as a difference of generations because we're like, okay, this is ridiculous. Why are they doing this? We have a language, but they're developing their own language, which is interesting in and of itself. But these kids are being raised by those people because that gets clicks and an algorithm. It's companies that are then having these clicks because that gets them monetary value. So they're not.
Another issue with education, because those parents are not educated in,
Yeah.
what we're educated in, and whoever's right. Again, I don't want to say I'm right and they're wrong, although I think I am, of course.
Mhm.
But that's another whole form of misinformation and the wrong information spreading, or information spreading incorrectly. And so then there was this one, like, I don't know if you saw it, this might be what you're referencing. There was like a little girl who was on, she, like, her mom had like a TikTok, I guess, and she was like recording her, and she's like, what did you learn today in school? And she said, I think like that the earth was round and that it rotated around the sun. And then she was like, and what do you really think? And she was like, none of that's real. And I was like, this is like a 4-year-old. Like, this is like a 5-year-old, like, little girl or something. I don't know if she's 4 or 5. I can't tell. But
Yeah.
she's a very young girl who,
I mean,
like, her mom just has told her that the education system is lying to her.
I mean, yeah, it's indoctrination by their own parents, and the problem is because it's focused on it's more focused on education system is lying. Stop telling this stuff to kids. Those kids are going into it, and they're not there to learn. They're there to just sit there and be there. They're not gonna. They might get good grades, but that's because they're doing what they have to do.
Mm-hmm.
So we're not getting rid of the problem through education because those parents are the ones who are causing the problem with it. I'm not saying we have to get rid of the parents, but I personally have no idea what we could do, but it's.
Well, I think that also needs to become about sort of educating those parents on like because those parents are only teaching it to their children because they believe it too, and they want their children to inherit their own beliefs, right? But I think that there is a lot of, problems with how things are communicated. And I think a lot of it does have to do with algorithms. A lot of it has to do with just generally like the algorithm likes when you take something that isn't that big of a deal and turn it into like more of a big deal, right? So if I take a study that really didn't prove anything, and then I turn it into something that really, really proves this sort of out there thing that it doesn't, then the algorithm is going to see, oh, I have evidence to back this really wild claim. That's going to get clicks and views. And then because it's a wild claim, there's even going to be a product that they could advertise on whatever I'm using that might get more clicks, right? So that's what's going to get that's what's going to get pushed. And I don't think the algorithms are doing it on purpose to be the algorithm is not saying like, I think it exposes human behavior more than it exposes the algorithm itself, because the algorithm is just capitalism.
Yeah, it is. I
So
mean, it's
the
purely money.
the algorithm is just saying, how do I get this person's attention so that they don't go to this other competing app?
Yeah, and I know we are a capitalist society. I fully believe in that. I'm not saying we should have complete government control, but there needs to be some restriction. There needs to
I'm
be
not
something
saying
on
that.
this.
I'm not saying it's a good thing. I'm not
Yeah,
pro algorithm. I'm just saying, like, it does also, like, if we are going to create policies that inhibit this, we also need to understand the effects on human behavior, how behavior affects the algorithm and vice versa. because without understanding the behavior component, I don't think we can put the right restrictions on the algorithm that will actually have good effects or positive effects. Because, you know, the algorithm itself is there so that we click on ads. That's why it's there. I'm sorry, did you want to?
As like one of my, I don't really know, I don't think it's really even a hot take or a controversial statement, but as someone who kind of went through and did things like the history of like psychology, cognitive science, and all that stuff, it's it's kind of disheartening, but I think important to realize like all of the most refined techniques and models that we have in like studies of psychology and behavior are employed to the ends we're talking about here. Like it's not just like ho hum algorithm. It's like decades of very targeted manipulation that's launched at everybody all the time. And I think it's hard to capture that for people who don't for people who don't really have any context. I think everybody here does, but like it's not just algorithm or not just capitalism. It's like it's quite disheartening as someone who's, I don't know, looked at like the history of this stuff. It's like this is where it's really come into being, is this sense like, well, why don't we have better versions of, okay, like I think like Inside Out, I use Inside Out, the movie Inside Out, as a great reference point of like, we don't, it's a very nice accessible version of models of like emotion and core memory and how how does someone's subjective inner world work. And we have it's a nice model for that, but it's sort of like, why are we so limited in some of these models versus some of the applications that are really refined and targeted at destabilizing us in this way. So that's a bit of a side rant on another topic, but like, yes, it is the algorithm, it is attention, and it's also like, it's not just sort of like haphazard. It's very targeted. Yeah.
What I find interesting is like the people who aren't scientists necessarily, like by trade, who find their way to sort of defeat the algorithm to get what they want. I've been sort of deep diving just as like an observer into that on social media, because there's this one girl that I follow, and I think she's like getting her degree in I'm not sure if it was psychology or political science. I don't know what it is, but she doesn't talk about that on her account at all, right? And her account blew up kind of quickly, and she was like, yeah, the way that I did that was I realized that like Instagram wants my attention and wants me to click on them. So what I do is every time I post a video, I turn it off. Like I'll post a video and I'll ignore it for 24 hours until I get a huge number of like comments notifications. And then I'll click on the comment notification so that it knows that if my videos aren't getting pushed out and I'm not getting comments, I'm not going to use their app. And then it starts pushing my videos out more and more because they want me to use them instead of like Twitter or something. And it's like, that's so interesting, like that people are so like in tune with this is how it's working, right? But it's so true. Like that's how it's working. It wants your attention. It wants you to click on it. If it thinks that this is how you're going to click on it, that's how it's going to behave. And the fact that people are so observant and aware and yet also very much using the applications is also a whole nother topic, because I think we're all aware, but I think we're all just also complying.
Well, and that's there was something a long time ago, and I apologize because I have the flu or something like it, and I don't quite remember. I wasn't around at the start of things as much, but basically, I think one of the big differences now, both in like education and also like conceptualizing stuff, is the emphasis of this sort of external thing. Like I kind of always think about how, like if you ever see clips from like the early 1900s or whatever, and when cameras were very rare, and you see people that either wouldn't smile at all, or maybe in like the 70s or 80s, and like, oh, there's a video camera, and people would, like an everyday person would be like not sure how to react to it, or they'd make a very goofy face that would be very like out of place nowadays.
Mhm.
But now it's this constant sense of you are speaking, like there's this permanent audience impact, and I think that might affect a lot of things in terms of yeah, some of the present shock things that I talk about, but that the book talks about, but also like even in education, even in like we're not just thinking about making content, or like, or maybe a better way to say it is like it's always about making content. Like you are now groomed that however you interact with the devices, like you better be thinking about how to satisfy the content machine.
Mhm.
And that is just a very different, like that. If you talk to people from different generations, it's very different to see how it affects their like structuring communication and stuff like that.
Yeah.
On some of those notes with the whole different generations, it's interesting to see how each generation can take in information as well, because we used to be a much more paper-based society, obviously, but now it's all digital, and there's even assistive technology for people who have ADHD or autism to help them go further with their ideas. But as someone who has ADHD, I've seen like it's actually easier for me to read something on paper because I can get it down easier because there's something physical in front of me instead of just lights shooting at my eyes.
Yeah, I've heard some people talk about like books, and even myself. I honestly don't like books. I've always had a hard time with books themselves as like a medium, like just staring at something and reading it. But that's like I'm drawn to books now because of that specifically, or even something like maybe like an iPad or a digital reader that's like completely locked away from everything else at least. But like the fact that you you have a book, or even I saw something recently about how people are collecting like VHS and DVDs again, just because nobody's gonna steal. They're worried about someone stealing it, or like digital copyright coming and taking it away, or like, oh, I don't have to pay for this every month. I have the physical object now. And I think there's something too, like I think we talked about this earlier in terms of like the ability to focus or work through things, or stay consistently focused on something again. But yeah.
Yeah.
I mean, that's also another problem with current generation education focus.
Yes, it's a huge, I know, so not me, but I know someone who was a kindergarten teacher and loved their job, family friend, never had a single complaint. And after COVID, she went back to work and she said that she has never had, or sorry, she was in work. And it wasn't even the year after COVID, it was like a year after she had gone back. She noticed that her students just could not, like, she taught them the first thing that she had taught them pretty much all year in like February of the school year, and she was so excited because she just like had such a problem, which I think also goes back to the iPad kid thing with Gen Alpha, because I think when you give children, I think with COVID, if you didn't have a nanny who lived with you, or you know, a lot of resources, then you had really no choice but to give your kids an iPad if you were working from home and needed your children to be quiet and occupied. But I also think that that worked backwards in terms of their development of those skills of being able to focus.
Because it also gets them addicted to that stuff.
Exactly. So they're all sort of, I don't want to say that I have ADHD. I don't they might be ADHD, but I'm not a doctor,
Yeah.
so I don't really know how
Not
to categorize.
everybody has it, but it's more just because of technology, our attention span has gone down because of the quick response dopamine and quick short bursts of that we get from looking at bright colors and stuff. Like on my phone, I recently turned off all colors. I'm now just in grayscale because I'm trying to get work done most of the time. So I don't have time to look at the shiny colors, oh shiny dots, all that. But because our brains are looking at that constantly, it's constant dopamine, even if it's not a lot, and it's very short bursts as well. So it's kind of, honestly, the phone itself is more addictive than, maybe not more addictive than all the drugs, but definitely a few.
I mean, I think it's I think I would say it's as addictive as many drugs.
Yeah, like I'd say maybe cocaine. Maybe not fentanyl, but definitely cocaine.
Probably. I think it's
Well,
probably.
it's interesting that for our cognition, it's very much tied with emotion. And like, I think that dopamine is the currency of our brain, of neurons. I mean, it's like if you want anything done in an economy, you have to have money. Otherwise, there's no like exchange, there's no activity that's happening. In the same way, I think that like dopamine is the currency of neurons, that you can't really get anything going structurally unless there's dopamine involved. So, as far as cognition is about attention, and attention requires dopamine. We have these hacks that have these screens that have hacked, and these algorithms which is hack that mechanism. And now it's just
No, I had a
like,
question.
no one's interested in anything unless there's dopamine there. You have to make something relevant to them, salient, and to have a valence for them to be interested in learning something.
On this, actually, I could think about how do you describe like if we're talking about these algorithms that feed into these certain things, is what is like, how do we attribute some level of agency to those algorithms? Right, because they are kind of growing and learning in response to its fuel is us in a lot of ways. Its fuel is us and our attention, and yeah, it's the economy of these algorithms and social media or the internet or whatever is you could say maybe our attention is its fuel, its currency, if that makes sense. And I think I actually think that like, apologies if this was already covered, but if you look at like thumbnails, right, they're almost a caricature of attention. Like, have any of you seen those drawings that show like where you're most sensitive on your body, and like they exaggerate the size of it? Have any of you seen those drawings before?
I don't know about
Yeah, body
exaggerating,
map.
but yeah.
It's kind of like that, but for our attention, right? Is that's kind of like if you look at the way thumbnails are designed with the the way that they scheme the colors and the fonts and the text and the images and all that stuff, like it looks a lot like if you were trying to just directly reach into our attention and grab it, right? And the sad thing about that is, like, listen, if you're a busy person and you've got a lot going on and you're multitasking at work or school or whatever, and you're browsing, say, through YouTube or the news or whatever, like, if you're not at full attentional capacity, like, what's going to grab your attention? It's going to be stuff like that. And, even when we package things, like when you package videos or whatever it is like, okay, yeah, you're trying to do this in a way that it entices people's attention. I don't think that's a healthy thing. It's good branding. It'll get the job done, but also at what cost? And I think if this was done in small amounts, I don't think it would be an issue. But because of how massively this sort of principle has scaled in industry and everywhere, even academia, I think academia does a very similar thing. They just do it in a different way. They hide things in a different way with the way that they say information. I don't think it's a good thing. I think it is kind of attacking at our attention spans, potentially even our intelligence and comprehension skills and all of that. And it does remind me of the movie Idiocracy, if any of you have seen that. It does remind me of that. And it does kind of feel like we're leaning into that. But then if we're going to bring AI into this, I also think about, like, what is the AI being trained on? Right? Like, would you say it says more about the system? Like, what is the AI being trained on? Right? What is its fuel? Like, people say, oh, you are what you eat, you are what you consume, whatever, in terms of your content or whatever. So, like, what are we giving the AI? And
Right,
this isn't
some
just
total
AI, it's
human output.
in general about the way we raise and we grow and we build other forms of intelligence, whether it's AI or ourselves or animals or whatever.
Yeah, I mean, the AI is trained on human output and is limited to the quality of that output. So we're hoping that the internet so far is good enough to oh gosh, if that's a saturation limit moving forward, and like human output is going to be decreased because no one is like doing attention to it, then like what will AIs be trained on in the future? Probably less quality human output, unfortunately.
And I guess there could be like a model you could do for it where at the present we have like human ingenuity, and as it goes on into the future, the quality of content just gets worse and worse and worse as we are being affected by that worse and worse content. It'll look more like the first quadrant of a irrational function.
Then again, you can also ask yourself about like, you know, let's just say something is unhealthy for a human, right? To eat or whatever. Does it have to be? Is the unhealthiness sort of dependent on the observer and that the system isn't just able to deal with that kind of information? Right? Like I talk about things like allergies and all that and you know, desensitizing to that and training on that type of stuff. And it's like, what does that look like for also other forms of information processing in, you know, a system, organism, whatever you want to call it? And you know, is it that the information is bad for us, or is it that the information is bad, or that we can't handle the information? And perhaps we have to evolve and adapt to some new way of interpreting the information so it's not negative for us.
I mean,
Right? Because I mean, there are people that like they can be exposed to whatever and they don't have as much issues as somebody else.
I think it's the latter of the two where it's kind of observer based, because you can give someone like take for instance, like you said, food. We like the taste of sugars because it's associated with good things, but then we don't like the taste of bitter things or sour things for basically from the moment we're born, because our evolution has trained us that bitter things are normally poisonous. So we are adverse to those tastes, but you can train your brain to like that. And someone with, I'm not going to say genetic mutation, or someone who has a genetic line that's previously been able to eat these things much better, they're not going to have as adverse a reaction the first time around. So I guess it's more just it's observer based, but more from an evolutionary standpoint, where the observer itself can change and it's not always set in stone.
In previous episodes, I've talked about like sensory deprivation. Right now, let's think about this a little more abstractly, about the way the negation of the information, the deprivation of the information gets you to interpret things differently, right? As almost a form of training. And at least if we're on the topic of like attention and clicks and all that type of stuff, is like, have we sort of seen what happens if you're really deprived of sensory information for a while and then you go back and you look at it? It's like, you know, like if people are used to eating sugar, sweets, you know, spices all the time, and then they deprive from that for a while, they disconnect from it for a while and they go back to it. When they come back to it, everything's going to stick out a lot more. Right. And you know, I don't know if I'm in a position to say whether any of these things are good or bad. I could say what I would kind of prefer based off of the way I look at things. But I think there you go, insulin sensitivity. Yeah. I mean, my thing is that if we want to evolve as a society, I think social media is very important for this in whatever form that it takes, right? But what is a healthier way to do this? Because at the end of the day, a lot of people will make their content because of the audience. It's like, you know, the audience demands this to kind of get their attention or whatever. This is, you're almost designing things for the audience. You're designing things for another observer, right? And how can you both have some shared perspective that's mutually beneficial, so where you're not technically preying on the, you know, consumer of the material in the same way?
I think that's a great question. I've been thinking about that a lot. I've recently decided to go more into making content in quotes, which is weird for me personally, but it's also like the old saying of like there's a famous bank robber who's like, why did you rob so many banks? Why did you rob banks all the time? He's like, why rob banks? Because that's where the money is. And not in a sense of money, but more like if you do want to reach the audience, you have to basically make bite-sized content, even if it leads to other things. But to your point is like, how do you, as a conscientious or enlightened content creator, attempt to, like, can you do it? I think it's a great, I think it's I'm not even so sure that it can be done, honestly. I'm agnostic. I would like to think it can be done, but like, can you make content in a way that does it? And even like we talked about all these things about competing pressures on understanding like long form content, about having things there, and it's like, well, you know, maybe your stuff has the bite-sized stuff, but it leads to more meaningful, this, you center your discussions, you have a long form podcast and you center that in a way that has good values, or you know, a good take on the future, whatever you want to say. But it's like, I think it's a very legitimate question of like, how do you interface with this and acknowledge that is kind of a cost of entry thing for certain stuff. I think it's an interesting dilemma too, because it's like, I feel you know, the internet at large is this amazing opportunity to provide insight. Like you can talk to somebody right now who has a very different lived experience than you did, and you can do it in seconds. You could probably find somebody new, or just go somewhere, like the compassion, the empathy, the perspective offering that it has is tremendous. Like nobody could do that before. Like you could get a lot of people of a similar, you know, situation and look at videos from them now in ways that hasn't been remotely close, even 15, 20, 30, 40 years ago. No chance. Most of my friends are internet friends. Most of my best friends are only people that I met through internet, very niche internet things. And at the same time, the internet is also this it's, you know, now it's misinformation and all these other things, and so it's like, how do you deal with that? And I think it's a very, I would almost I'm not saying this should be a hackathon that we do or something per se, but like, I think that is a huge question that extends beyond like a lot of things. Like, how do you consciously attempt to interface with this internet thing, with this content, with this social media in a way that is offering like some kind of progressiveness or like goodness or whatever you want to say, while being fully aware of the very, very targeted, negative, distortionary, like the bad side of things too. 'Cause I don't have a lot of answers, but I'm curious about it.
I mean, I think that kind of just, again, plays into education, because we have these bite-sized things. Most of the time, for 20 seconds, 30 seconds, YouTube shorts or TikToks or whatever you like to watch. And then there's the longer form videos that go with it. But then the problem with that is those longer form videos don't get clicked on as from that traffic that's going through the shorts, because those people are going through the shorts for that dopamine hit. They're going through there for just to get a little attention here and there. So they're not going to sit there and watch a video, or if they do, they'll just have it on in the background. You see these people who are scientists, or maybe just science curious people who actually do appreciate science and have interest and know quite a bit about it. So they go on here and they do these very interesting things to get you to click on the longer form videos, and sometimes it works, sometimes it doesn't. Exactly. And because a lot of people don't do it, and a lot of the time those people who are going through those videos aren't kids, we don't get education that much, because those videos are made to educate people, but it's more adults that are clicking on those videos, because kids are clicking on the videos that aren't very science-based. They're clicking on the videos that are very just, like, heck, I'll say Cocomelon even, or those skibbity toilet whatever thing, I don't even know.
W Riz, L Riz, Skibbity Toilet.
And those are the things they're going to see, and those are things they're going to learn. But because of those things being the first things that they're learning, they're evolving with a whole different worldview, even without parents being indoctrinated, because you can see kids that have prestigious parents, They're very academically inclined, the parents, not the kids. So they're sending their kids to private schools, they're sending kids to do all these things. But then the mistakes they make a lot, and we do it because we try and have a good life for our kids, is we give them a phone. And I'm not saying we just shouldn't give them phones, but there are things that go with it that can seriously impact their learning and mental development as well.
When we choose an easier way of things and we keep that up for a long time, are we selecting for so-called dumber traits or capabilities, right? And again, I think that is all very observer dependent, which is a word I'm throwing around a lot for some reason. But we can make, I mean, can we talk about the benefits of having a sort of attentional economy like this? Are there,
Efficiency.
besides just making somebody money or whatever, what are there some other bigger, let's say philosophical benefits to having something like this? Because it does work. It does.
I mean,
it does
if we could like compact, let's say you take one of the Feynman lectures that's like an hour and 30 minutes long, you can somehow compact that into like 60 seconds of information, or even better, like 30 to 45. That's a lot of information that that person who's watching that is getting, and because of lowered attention spans and everything that's just diminishing because of these things, that's gonna maybe not bring back some of that attention span, but that's going to be something that's actually very beneficial because it's quick, easy communication and passing on of knowledge. But right now, we haven't been using that to the fullest, which is the biggest problem I see with passing on this type of information that isn't the best so far.
Yeah, there is something to be said for information exposure. If you're watching, let's say, educational shorts, or packaging good educational bits into an attention economy like that, a person can get exposed to a wide number of ideas that are very good ideas to think about, and they can, if they're doing it correctly, if they're integrating the information that they're learning, they can have a very broad sense of education that way.
Yeah, there's just a problem with some of that, which is like, how do you do it? Like calculus, how are you going to teach a lesson on integrals in 30 seconds to, say 11th grader or something?
Right. So I mean, you can have like bits from 3 Blue 1 Brown or something, which will expose students to these topics, so that the students know that these topics exist, although they might not have depth knowledge of any particular one. It's broad and thin, but it is.
Yeah,
it could be useful having a low detail map of the territory.
Yeah, because I agree with that, because like some of those kids are going to be going into high school or college, and they'll take some of those classes that they look at the shorts that they think, oh, that's interesting, so they come back to that. But even from there, it's still some of those kids that do that. Let's say you have 20 kids that all have that inspiration moment where they see that short and they say, that's something interesting, I want to learn more about that. They go to college freshman year and they sign up to take a course on that. But then because it's not what they thought it was, where it's actually very math based, it's very rigorous, that you have to have very good critical thinking. Some of those kids are going to realize they had skills that they never knew they had and be able to excel greatly. But some of those kids are going to be disappointed because it's not what they thought, where it's just, oh, let me think about this one thing. Oh, that's that.
I mean, at least it seems that it's true that the way you're exposed to information first, especially, can shape a lot of what you're doing after. It's a prior, right, in a way. And there are people that, like, kind of touching on what we were saying earlier in the conversation, that, if they just have a really, let's just say an unenthusiastic math teacher or whatever, it can kind of shape the way they lens math, right? And it's almost like a sense of learned helplessness. I think that's a sense of a learned helplessness, actually. And as we've discussed before, that can be a very, very negatively powerful way of looking at and experiencing the world. All right, thanks everyone for today's joining today's Polymath Salon. Before we exit out of here, I want everyone to kind of plug whatever link or website or social media you want to promote. Nicholas, do you got anything you want to promote?
Not much. I mean, LinkedIn is the only thing I'm on, but not really looking for work right now. So
Got it. Jesse?
I'll just say you can find me on LinkedIn too. I'm a little under the weather, but yeah, LinkedIn.
Dugan?
Yeah, LinkedIn and my Twitter profile, X.
Awesome. And then I think Michael is logged off, but I can link his Substack anyways. And then me, which I'm here. All right, yeah, so thank you everyone for watching. We'll catch you for the next one where Dugan will be presenting as the lead speaker on visual perception of non-Euclidean spaces and higher dimensional spaces. That's going to be very, very exciting for me. I'm super
When is it?
excited. That's Saturday.
Saturday.
Okay.
Yes. All right.
See you all
I'm
next
excited.
year.
All right. See you guys later. Thank you.
Uh-huh.
Bye.
Bye-bye.
see y'all later. Bye.
Bye.